So piecewise, the key word being here is piece. We're going to have pieces of functions. Okay, we're going to look at pieces of functions and we're going to put them together. All right, so here's what a piecewise function looks like. Instead of having just f of x is equal to x squared minus 2, we've got this brace right here, and we've got two functions. So what that means is part of this function looks like x squared minus 2. The other part of the function looks like x plus 1. Now, to decide where it changes, that's what this inequality is all about. Okay, it says it's x squared minus 2 if your x is less than 1. So our x values are less than 1. So we're talking about to the left of 1, we're going to look like x squared minus 2. When x is greater than or equal to 1, x value is greater than 1 is to the right, then we look like x plus 1. So I want you to write that. When you deal with piecewise functions, I want you to look at these inequalities and I want you to say, okay, this is the left side, this is the right side. Now, they don't always do that. They don't always do it left, right. Sometimes they put the right side first. So you really do have to look at that inequality. And it points in that direction. Look at that inequality. It points that the tip, the arrow, is going to the left. Okay? From the right side, the arrow looking part is going to the right. So use that as kind of a hint. Now, here's the easy part. Okay? Evaluating piecewise functions. So A says, what is f of negative 4? Well, ignore the fact that we're doing a piecewise function. If I just asked you what's f of negative 4, what do? What do you plug negative 4 into the function. So that's what we're going to do, but we've got to decide where to plug it in because we have two functions. We have two pieces here. So does negative 4 fall less than 1 or greater than 1? Less than 1. So we plug it into the left side. Okay, so this, I don't know, you can write left or whatever you want to. But negative 4 is less than 1, so we just plug it into that first piece, negative 4 squared minus 2. You can do it in your calculator, you can do it by hand, but be careful when you square that negative. You have to put parentheses around it. So that's what, 16 minus 2, so that's 14. Okay, B, f of 0. Is 0 less than 1 or greater than 1? Less than. So this also goes into the left. So we've got 0 squared minus 2. Well, that is negative 2. Okay, f of 1. Which piece do we plug that into? The left one or the right one? The right, because the right is the one that has the equal to under it. So this goes into the right piece. So we've got 1 plus 1, that gives us positive 2. And f of 2, that goes into the right as well because 2 is greater than 1. So we've got 2 plus 1, that gives us 3. Okay, so that's pretty easy. We've just got to decide which piece we plug it into. Now, you might be asked to graph these things. Okay, you might be asked to graph these things. So I need to bring my function down because I can't see it. X squared minus 2, x plus 1. X squared minus 2, x plus 1. Now, on your table there, I have a big line right in the middle. Because here's what I want you to do. We're going to use our calculators. Okay, we're going to use our calculators, but we've got to know where to change. So right there at that line, I want you to put the number that's beside the inequality, above it and below it. So we're going to put 1 above it and below it. Okay, 1 was the number with our inequality here. X is less than 1, x is greater than or equal to 1. So we put that, I want you to put it above that line, and I want you to put it above that line, or below that line, because that's where the function's going to change. So I need to pick some x values that are less than 1. So I'm going to go this way, and I'm just going to count by ones. Okay, 0, -1, -2, -3, and then I'm going to count up. 1, 2, 3, 4. That should probably be enough. Well, I've got 5 on the other side, so I'll put 5 on my side. 5 values, just so we're even. Okay, here's where we're going to use our calculator. Okay, this side, this part up here is the x squared minus 2. This part down here is the x plus 1. So we're going to put x squared minus 2 into our y equals, and then we're going to go to the table, and we're going to fill in those y values. X squared minus 2. Go to the table. -3 is 7. -2 is 2. -1 is -1. 0 is -2. I already knew that. And 1 is -1. And then I'm going to do the same thing for x plus 1. I really don't need my table for that. I just add 1 to all my x values, right? 2, 3, 4, 5, 6. Okay. There's one more thing that we need to do before we start plotting these points on our table. Okay, this first piece was when x was less than 1. This second piece was when x was greater than or equal to 1. So here, I'm going to write beside this open circle. Okay, so at that point, 1, -1, I'm going to put an open circle because technically for that piece, I'm not supposed to equal 1 for my x value. But I still want to put where it would be. So I'm going to put an open circle there. The second piece has the equal to, so I'm going to put a point at 1, 2. Okay, open circle at 1, -1, point at 1, 2. So let's plot these points. -3, +7, -2, +2, -1, -1, 0, -2, 1, -1. I put an open circle right there. And I'm going to go ahead and connect those parts of my graph. I'm going to go ahead and graph that part of the curve. So I've got part of a parabola here. I don't have the whole thing. I just have part of it because I only have the part where x is less than 1. Then I'm going to plot the points for the second part. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, and guess what? It goes on and on and on. You just graphed a piecewise function. So it looks kind of complicated, but the key is that point where it changes, knowing where the open circle is, and knowing where the point is. That's the biggest part to it. Okay, let's do another one. Now, sometimes piecewise functions have more than one piece, or excuse me, more than 2 pieces. Okay, you can have as many pieces as you want. Most of the time, we're just going to see 2 or 3 pieces. Okay, so this one has 2 places where it changes. It changes at -2, and it changes at +1. So let's start with just evaluating. Okay, let me number these pieces. I'm going to say this is piece 1, this is piece 2, this is piece 3. Since we can't really talk about left and right, because then we've got I guess we could do left, middle, right. All right, G of 5. Which piece does that fit into? Piece 1, 2, or 3? 3. Okay, piece 3. So we plug it in. That's 5 squared. Gives us 25. Because 5 is greater than 1. Okay, -2. G of -2. Which piece does that fall into? Piece 1. Okay, piece 1. Because piece 1 has the equal to -2. So this is piece 1. So it's just x. So it's just 2. Or excuse me, -2. Okay. G of negative 6. Where does negative 6 fall? Piece 1. Piece 1. Because negative 6 is less than negative 2, so that's just negative 6. How about G of 1? Piece 2. Because that's where it's equal to 1. So we've got 1 minus 1, which is 0. G of 0. G of 0. Which one does that fit into? 2. 0 is between negative 2 and 1. So piece 2 is x minus 1. So 0 minus 1 is negative 1. And then G of negative 1, where does that fall in? It also falls into piece 2. So negative 1 minus 1 is negative 2. All right. So we've got 3 different pieces we've got to worry about on this one. We've got x minus 1, and x squared. Let me write that here. X minus 1, x squared. This was where x is less than or equal to negative 2. Between negative 2 and 1. And greater than or equal to 1. Okay, so that means that here at this first line, we need to put negative 2 above it, negative 2 below it. On this second line, we need to put 1 above it and 1 below it, because those are the x values where our function is changing. It's transitioning from one function to another function. Okay, so let's pick some x values here to fill in our table. So we need to go less than negative 2 over here. So I'm going to go up to negative 5. And then negative 1 and 0. And then 1, 2, 3, 4. Okay, so for that first part, it's just x. So our y value is the same thing as our x value. And do we have an open circle or a point at negative 2, negative 2? A point. We have a point because it's equal to negative 2. All right, for the second piece, we subtract 1 from all of our x values. So that's negative 3, negative 2, negative 1, 0. Do we have a point or an open circle at negative 2, negative 3? Open, because it's not equal to negative 2 for this one. Okay. How about at 1, 0? Open or closed? Is it equal to 1? Does the inequality have equal to 1 for the middle part? Yes. So that's a point. Okay. The third piece, we square our x values. So we've got 1, 4, 9, 16. Whoops, that last part's not important. Okay. Open circle or point at 1, 1? Open, because we're not equal to 1. I mistakenly wrote that originally. Let me check and make sure. Yes, just greater than 1. Okay, so let's plot that first piece. Negative 5, negative 5, negative 4, negative 4, negative 3, negative 3, negative 2, negative 2. We get a point, and that's where we stop with this piece. Okay, middle piece. Negative 2, negative 3 gets an open circle. negative 1, negative 2, 0, negative 1, 1, 0 gets a point, and it stops. We just have this segment right here in the middle. We don't have any arrows or anything on this one because it's just between negative 2 and positive 1. And then we've got 1, 1, open at 1, 1, 2, 4, 3, 9, and 4, 16 is off of our graph. This is a parabola, so try and make it look a little curved. Okay, don't just connect those in a straight line because this is part of a parabola, so try and make it look like a curve. I know it's kind of hard because you don't have a lot to work with there, but try and make it look like a curve and not a straight line. Okay? So those are piecewise functions. Okay, I didn't really use my calculator much on this one, but you could have. You could have put those into y equals and looked at the table to get the values, but these were pretty simple functions to deal with. Now, I'm getting ready to give you some practice. I didn't have an example like this, but sometimes these pieces will meet. Like right here at negative 2. Instead of those being at two different y values, sometimes they'll be at the same y value. Okay, sometimes they'll be at the same y value. So part of what it tells you to sketch the graph, and then it also says determine whether or not it is continuous. Okay, in order for it to be continuous, the two pieces or the three pieces have to meet up. There can't be any gaps. So this one is not continuous, and neither is the other example that we did because there were gaps in the graph there. If they don't meet up, then it's not continuous. If they do meet, and it's just one continuous line, even though it's different pieces, it's one continuous line, then it is continuous. Okay, so add that to your right below your graphs here. Write not continuous, because there are gaps in the graph. Okay, neither one of these were continuous, but some of the ones on the practice will be. Okay, whoops, can't spell continuous. There's another U in there.